Hello, I didn't really get accelerometers initially. So this is a video explaining accelerometers and how I understand them. So as you can see here, there's X, Y and Z. X is that way, Y is that way, and Z is down to the center. So right now on my screen I see that Z has the highest value. It's around 9. Should ideally be 9.8 because of the acceleration due to gravity. Now, X and Y should ideally be 0, but calibration hasn't yet started. So, I'm getting around 9.8 through Z, which is to the center of the table. So if I moved X in such a way that gravity is now acting on X, I should see that X has now 9.8, around 9.8. So gravity is now acting on X, and Z should ideally be 0. So we're getting close to 0, we aren't perfect. And Y, which is acting that way, if acceleration is now on Y, I should get 9.8 on the Y axis. So that's around 10. If I flip it the other way around, I'll get positive 10. So I can detect the acceleration due to gravity if I'm tilting in the y-axis, tilting in the x-axis, and then tilting in the z-axis. So if right now acceleration due to gravity is pointing down, so I'm getting 9.8. If I flip this board over, acceleration due to gravity should be inverted. So I get minus 10, which is good. So this accelerometer will give me details about how to tilt in these directions, and only that data. It does not tell me if I'm moving forward like this. So if I move this forward and backwards, I would get no difference in acceleration due to gravity in the x and y direction. Whereas also, if I move this way, I should get no difference in acceleration due to gravity. I'm doing the same thing here. I'm getting no difference in acceleration due to gravity in there. If you did see some acceleration due to gravity, this might have been because when I'm moving this in here like this might be tilting a bit. It's a bit wobbly. So this is what this shows. And so if you pick something up when you tilt it, or if you had a phone and the image was in this direction and you've tilted your phone, you can detect that your phone has been tilted. Or if you're playing a game, you tilt your phone like this, you can detect acceleration due to gravity. You can also detect how much acceleration due to gravity is between x and y and shared between y and z. So if I am now tilting this board, I will see an increase in acceleration in y and a decrease in z. So if I tilt this slowly like this, I see acceleration increasing in y and a deceleration in x and z. Because z gets less and less and less, lower and lower, and then y gets to the peak. Because at halfway point, there will be some acceleration due to y and some acceleration due to z at the same time. And I think that's quite cool. So you can create a vector between acceleration due to y and acceleration due to z and create an angle of inclination if you wanted to. So you could see how you're inclining between x and y, or you could just look at how much it's been tilted.